Thanks for stopping by to check out another episode of Vintage Audio Review. Back in episode 111, I did a review of the Quad 34 preamplifier. There was some interest in my doing a review of the matching power amplifier, which would be the model 405-2, and as it turns out, my friend who owns the Quad 34 preamplifier had the matching power amplifier, the 405-2. Now, there is a model 405 which was manufactured around the mid-70s, let's say around 1976. There were some improvements made to that model, hence the 405-2, which sold in 1985 for $650, or about $1,900 in 2024 money. It had a couple different ratings for the power depending on the frequency, but at the lower end of the band it was 0.02% THD, and at the higher end of the band it was 0.05% THD, and that was at a power rating of 100 watts into 8 ohms. The frequency response likewise was spec'd a little bit like that. At 20 hertz it was rated at -1 dB, and at 10 kilohertz it was -0.5 dB. So that was kind of the basic specs of the 405-2. Depending on where you read, the 405-2 supposedly sounded better than the original 405. And when I got this, the first thing I did was hook it up to my loads and just kind of look at it. It supposedly was working right as my friend was using it in his little setup. He sells records online, and he has a turntable set up and some speakers, little speakers, and he listens to records just to see the quality of them. And this was the power amp used along with the Quad 34 preamplifier, and he decided that it would be nice if I reviewed this as well. So that's kind of how I got it. And as I was saying, the first thing I do is to hook it up to my QuantiSylum analyzer and some loads and kind of just see where we're at. And at 2 watts it already had close to 0.5% THD, which isn't normal. And as I brought it up to my first test level at 5 watts, the distortion was right near 1%. One channel was a little bit better than the other channel, but something wasn't right. And so I popped off the covers and started measuring voltages and looking at the schematic that I had. And long story short, it turns out that this was set up for European voltages. Now in the back, in a moment you will see there's just the standard IEC power cord, and there is no voltage selector switch on this version of the 405-2. Earlier versions of the 405-2 had a voltage selector switch. This did not have that, and what I discovered was that the output voltage were about half as what they should be according to the schematic. And then I started looking and found out that the transformer was wired for 240 volts going into it rather than the 120. Luckily it was pretty much an easy fix, just move some jumpers around or resolder in some jumpers on the transformer, and then I got the voltage up to where it should be. And I'm thinking, oh, this is great, it's going to look good now. Well, one channel looked pretty good and nothing was really wrong with it. However, the other channel had a bunch of distortion. We're talking, it was over 2 or 3% at 5 watts into 8 ohms. So I needed some assistance trying to troubleshoot, and in the process of troubleshooting, my probe slipped. This would be a DMM probe. I must have hit 2 places it shouldn't have, and it killed the one channel. It blew the fuses, and some other stuff was blown as well. So at this point I started looking online through some of the forums, and I came across clone boards for the 405 or 405-2 that come from China. Actually, the same boards, you can see them coming from Europe, but I believe they're all sourced from China. There's a couple different styles, and I figured for the $60, $61 I think with tax and shipping, I'm just going to go ahead and buy a pair of the clone boards. Now, It does give dimensions for the heat sinks, and I knew that there was going to be a little issue with the heat sinks because they're a different size than the heat sinks here, at least where they would mount to the case. And I'm going to go into what I had to do to get them to work physically, but I decided it would be simpler since one board was having a problem anyway and the other board now had more problems. So it would be easier just to buy these clone boards and give them a shot. So that's kind of what I did. I hope I don't hear from a lot of haters for not using the original boards or trying to fix them, but considering the owner was living with the fact that the transformer voltage was half, so it was operating with a lot of distortion anyway, and when you see the frequency response of the channel that was still bad after I got the transformer wired correctly, he listens at a real low level, and I figured he's not going to care whether they're clone boards or not. So that's what I did. The data will all be with the clone boards, and as will be my listening experience with the clone boards. And we'll get into that a little bit later. And I will talk more about what I had to do to modify the clone boards to work with this guy. And, there'll be data and how it sounded and that kind of thing. And so right now we'll do a tour of the front. There's not much to see. The back also not much to see. And then I have the cover removed, and you can kind of see how things fit there. And then there will be some photos showing the mods I made to the case to get the clone boards heat sinks to fit in there. And it's not too difficult, but it does take, I would say, probably an hour with a Dremel and a thin grinding wheel and then a thicker grinding wheel to remove what you need to on the heat sinks on the chassis. You can't really tell from the outside there's any mods done, but anyway, I'll talk about that a little bit later. This obviously is the front of the Quad 405-2, as it says right here. The only thing of interest really is this power on-off LED here, and then this great big thing here is the heatsink that the output devices ultimately mount to. Here is the rear of the 405-2. We have our three-way speaker binding post here. We have our AC input here. Now I should point out that it says 240 volts as this was set up for European use. We have a 2.5 amp fuse that is underneath this cover. You just kind of lift up the little tab and pull that out, and there is a 2.5 amp fuse there. Here is our unswitched AC outlet power switch here, and of course the RCA inputs are right here. Here is a view with the cover off. This great big guy is our transformer, and they potted it up probably to make it quieter, I would assume. Now this is the input side here, and there is a jumper from here to here, and that is what you would use for 240 volts. Also, other things to point out are big filter capacitors here, and we have a bridge rectifier here for the power supply. Here is one of the output boards, and there's an output device here, two here, and then there's another one like this on the other side. This kind of just gives you a feel for what it looked like before. So this is a view after the modification was done for the voltage. The other thing to point out is that we have the new boards in. There's two of them, here and here, and they look kind of the same, but they're different. We have our inputs here. These are that's like the plus B. This is the speaker out. This is the minus B, and our two inputs from the RCA jacks go here. There used to be also small spade terminals for these guys, and I just cut off the terminal part, and then you could put them in here and screw down the contact screws for them. Here is an original board. I just kind of had taken this, and you can kind of just see what it looks like. These guys right here, this would be your input, and they're these are small terminals. I'm not sure the size, but they're not the standard kind of terminals that you would use. And I believe these two little daughter boards are the current dumping boards on this model, but this is what one of the original boards looked like. Here we have a view of the front heatsink before I did any mods. So once you pull off the circuit board from the heatsink, this guy right here. This is the power transformer here. You have a lip right here. You can kind of just see it here. There's a lip, and basically in order to get the other heatsink to fit, you just grind away this lip all along here with a Dremel tool. You just kind of have to be a little bit careful when you get in this area, but it takes maybe about 20 minutes depending on your grinding skills to get rid of this little lip here, and then all these holes will line up. And this view shows what it looks like after the grinding is done, and that's all here. So that lip has been modified. You can kind of see there's a bit of the original lip there, and it's all flat. And the other thing on the side where the LED is, where this guy is, you can see this little circuit board for the LED. That needed like a sharp marking knife, an X-Acto knife, to kind of trim that down a little bit. So when the new circuit board's heatsink mounts, there's nothing that's keeping it from mounting flush. Now, the other side has no little circuit board here, but this probably will need a bit of trimming with an X-Acto blade. So here's our standard THD SNR plot at 1 kilohertz, and everything that you will see, unless otherwise stated, will be with the new clone boards. And you can tell both those boards are pretty much the same. I mean, the same gain, same power out, of course, and the SNRs are a little bit different between the two of them. But overall, it's looking really good as far as the THD, and the SNRs are above, we'll say 74. So I think at 5 watts into 8 ohms, the clone boards are doing rather nicely. Here we have the quad putting out about 5 watts into 4 ohms this time, and you can see the gain is stayed about the same. The distortion, if you compare it to the 8 ohm load case, is a little bit worse. I mean, we're talking 0.009% versus 0.005%, not really much different. SNR is about 3 dB worse, which you kind of expect when you go to a 4 ohm load. Here we have the Quad 4052's frequency response from 20 hertz to 20 kilohertz. The specification is that at 20 hertz it is only down 1 dB, so we are pretty much there at 20 hertz at 1 dB. And at 20 kilohertz it's supposed to be a half a dB down, and we're maybe 7/10 or 6/10. So overall it looks pretty close to these specifications, and the channels are extremely well balanced throughout the whole frequency range. Here we have the Quad's frequency response from 20 hertz to 20 kilohertz, with it putting out about 5 watts into 4 ohm loads. If you compare it with the 8 ohm load case, it's down a couple tenths of a dB more at the high end of the frequency band, and at the low end of the band it's pretty much the same. Right now the Quad 405-2 is putting out about 93 watts into 8 ohms, and you can see that its distortion is doing really good. It's better than the specification of 0.01%. And what I'm going to do is increase the power level a little bit at a time. We should be able to get 100 watts. We'll see how close we can get before the distortion looks really bad. But before we do that, let's look at the harmonics. And you can see that our even or second harmonics are higher than the third or odd harmonics, which is not usually the case with solid state amplifiers, but it is the case with this Quad 405-2 clone. So I'm going to bring up the amplitude by 1/10 of a dB at a time, and you can see our distortion and noise level is getting worse, and we're at about 96 watts. We'll go up a little bit more. At 97 watts, you can see our harmonics are increasing. We're still at better than 0.09%, which is pretty good, but the SNR has gone down like 58 dB. And we probably can go up one more notch here. And we are at 100 watts. We're at 0.3% THD. SNR is about 51 dB, and the THD plus noise is minus 48 dB. So It's maybe just right at its spec. The THD is obviously higher. So this guy probably with the clone boards would be good for a little bit over 90 watts into 8 ohms. Here's the quad putting out about 96 watts into 4 ohm loads, and it's still looking pretty good, but it's starting to get a little bit distorted here. And as I increased the power a little bit earlier, it actually blew the 2.5 amp fuse. So I'm not going to run it any higher than this. Probably since the voltage is down, the fuse could be stepped up a bit, but right now it's already starting to go bad around the same power level as it did with 8 ohm loads. So it's kind of going to run about the same into 4 ohm loads as it does into 8 ohm loads from what the data has shown. In case you were wondering if there was any difference in the harmonics when you have 4 ohm loads attached, not really. It's looking about the same as the 8 ohm load case. Here we've got our even or second harmonic looking higher than the odd or third harmonic. Here's the 405's output impedance from 20 hertz to 20 kilohertz. If you look at the value, let's say through most of the band, it's about 0.05 ohms, which would translate to a damping factor of 160, which is really, really good. Here's the Quad 405's crosstalk, and there is no specification for it. If we use the value at 1 kilohertz, we can see that it ranges anywhere from about 37 dB to about 52 dB or so. So it seems kind of standard, kind of low here at the high end of the band for the left to right crosstalk, a little bit better, about 10 dB better for the right to left crosstalk. This plot shows the quad's THD versus frequency at a couple different output power levels, and that's into 8 ohms. I only showed the left channel in this case, and -7 would be the case where we're putting out about 80 watts into 8 ohms, and -22 would be about 2.5 watts into 8 ohms. Now the specification is that the THD should be better than 0.01%, except at 20 kilohertz where it should be better than 0.05%. Well, we're right at about 0.05% here at 20 kilohertz, and once we get above, we'll say 100 hertz, we do meet the 0.01%. At worst case, down here at 20 hertz, we're maybe 0.03%. So it's not looking too bad as far as the THD over frequency. Here's the Quad 405's multi-tone response, with it putting out about 4 watts into 8 ohms. And this is going to give between 13 to 14 bits of distortion-free range. Right now we're looking at the system noise level of the 405-2 with the clone boards in, and both inputs are terminated into shorts. We have 8 ohm loads applied. It says that it should be about -95 dB down from the full power point with A weighting on. So I'm going to go ahead and turn that on, but right now without the A weighting we're maybe -80, 4 dB, something like that. If I put the A weighting on, it's going to drop everything down, and we're probably about -95 dB or so. So it's pretty close to the specification with the A weighting on. Here is the Quad's IMD response, and it's putting out about 10 watts into 8 ohm loads. The two test tones are 19 and 20 kilohertz. There is not a specification for it. It's just kind of here for your enjoyment. Right now I have 1 kilohertz sine waves going into each channel of the 405-2, and what we're doing is looking at the difference between the input signal and the output signal. The input signal is in this purple trace and the output is in the yellow trace. You can see that the waveforms are 180 degrees out of phase. I don't know if that's good or bad, but that is what happens as long as you're aware of it. I guess it doesn't really make any difference. It is the same for both the left and right channels. I'm just measuring the left channel right now. So I'm going to go ahead and invert the output signal just so that I can look at the phase more closely. Here we have a 1 kilohertz signal going in, and I've got the scope set up in the XY mode so we can see the difference in phase between the input and output. And like I said just a moment ago, I do have invert clicked for the output so that we can see the difference in phase. It's very small here at 1 kilohertz. I'm guessing it's probably 5 degrees. It's not a lot. If we go to 100 hertz, we can see the phase has increased. It's probably, I'm not very good with Lissajous figures, but I'm guessing maybe 10 degrees of phase shift between the input and output. And if we go to 10 kilohertz, you can see there's very little difference in phase between the input and the output once you have inverted one of the traces. And here we are looking at the difference in phase between the two channels. In this case, there is no phase inverting of any of the channels. We're just looking at the difference at the output of each amplifier, and between the left and right channel there basically is no phase difference between the two channels with the same input signal applied. And this is at 1 kilohertz. This kind of shows the rise time, and our output signal is the yellow trace right here. Our input signal is a bit noisy, and I'm going to just kind of show you a little bit more what's going on. The rise time is stated at 6.21 microseconds for the output. Scope is calculating 6.21 for the rise time of the output. There is no specification for it. It's just kind of where it's at, and it's probably about 7 watts being put out into the load at this point. And we're just using the left load, and it's a 1 kilohertz square wave. This is the input signal. So right now I have the input is on going into the amplifier, and we're looking at the input going into the amplifier, but the amplifier is off, the power switch is off. As soon as I go ahead and turn it on, you can see it causes this distortion. I haven't normally seen that when I've done this rise time test, at least recently, where the input impedance changes things when it's powered on, but this is just there for information purposes only. Here is the frequency response from 20 hertz to 20 kilohertz. And what you are seeing are the clone board in yellow, and it was the first one that I installed just to kind of make sure everything worked. I still had the original highly distorted and apparently poor frequency response board in, and I wanted just to see a comparison between the two. Now this is after I got the transformer voltage set correctly for 120 volts, but this guy had a lot of issues, and that is one of the main reasons that I ended up with the clone board. As I mentioned, I had shorted out the good board accidentally with my probe, and with all things considered, I decided to spring for the clone board, and I think I made a good choice from everything that I have seen so far. As for the physical characteristics of the 405-2, it weighs in at about 20 pounds. It's almost 14 inches across, about 4.5 inches tall, and from front to back about 8 inches. The data shows that this guy performed pretty well. It did not meet the 100 watts into 8 ohms with less than 0.01% THD. It was more around the low 90 watts into 8 ohms or 4 ohms. When I hooked it up into 4 ohm loads and started getting the max power, it blew the 2.5 amp fuse in the back, and so its distortion was also getting bad. So with either 4 or 8 ohms, I would rate this guy, at least at 1 kilohertz, at about, we'll just call it 94 watts into 4 or 8 ohms. So that fell a little short, but I thought the frequency response was generally pretty good. The clone boards, I thought I would give them a thumbs up other than the mounting situation. As far as the performance on the bench, and I'll get into the sound in just a moment, as far as mounting them, they're, that took at least an hour to grind stuff, and you got to kind of be careful depending on where your power transformer is setting at the site you're grinding that. But once you grind it off, and you got to make sure it's flat so there's no little lip that heat sink's going to hit. Once all that was done, it went pretty smoothly, and I can honestly say that the heatsink on the interface worked really well. During my tests, when I started going to higher power levels, the front gets warm but not hot to where you can't touch it, and I turned off the amplifier. The cover was still off, and I touched the output transistors, and they were not cool, but they were just warm. I mean, you knew they were on, but they weren't hot at all. So the whole mechanism of getting the heat off the output transistor seems to work rather well. So that's a good thing. So there are a couple options for the style of boards. Some of them say they're a 4052 board. Some of them just say 405. One I got, I believe, just said 405, and they gave dimensions for the heat sink, and I knew ahead of time that there was going to be some mods that need to be done. And it's basically to the case. You saw in the picture where I ground off part of the chassis I need to get the boards to fit, and then the screw holes all aligned, and really at that point all you have to do is change the connectors that are the original connectors. They're small spade lugs, and you can connect the normal size spade lugs to them, solder them on. Now the inputs, they use a screw down terminal input for your left and right channels. So those I just cut the end off where the spade lug was and shoved the wire in there with the part of the spade lug that was still attached to the wire. So I just did that to save a little bit of time, and it seems to be working just fine. There is also a center spade lug that is like it's called PK ground or something. That doesn't need to be connected to anything, at least on the 405-2. It didn't need to be connected to any terminal, plus there was no terminal to go to it. So that was one other thing that I learned. And for my listening tests, I did connect my Wilson Watt 3 Puppy 2s to this guy, but before I hook up the Carver C1 preamplifier to it, I short the inputs, and then I just pop it on and listen for any turn on or turn off thumps. There's a small little turn on thump, very small, kind of normal. And as far as the hiss and hum, there was just a little bit of high level hiss, not any hum I would say, just more the hiss. You walk away 2 feet and it's gone. So I thought that was pretty good. Then I hooked it up to the Carver C1 and listened to music, and I thought it just sounded just fine. It had plenty of power to reach levels. I think it got up to 92 dB SPL, which is about the most that I want to listen to for a short period of time in the room that I'm in. And it just cruised along. It didn't stress. It got a little warm but not hot. It sounded just fine. I actually thought it sounded good as far as it didn't lack anything at all that I could tell. There's some things that say, oh, why bother going with the clone boards? These guys are easy to fix. But in my case, it just made more sense to just buy the clone boards. It gave me an excuse to actually do a video about it, and my friend will never know that there's clone boards in this, and he probably won't hear any difference in the sound because he listens to it at a low level, but at least we know that it's operating pretty much how it should. And it's a small footprint amp. It just had plenty of oomph to do what I needed to do. Now, if you were driving 4-ohm loads a lot, maybe it might have a little issue if you start increasing the power levels to it, but for the most part I thought it sounded fine. And if you go back to the video I did with the quad preamp, the max I could get out of that was about a -4 dB output before it started distorting a lot. And since this guy has an output of 35 dB and some change, it kind of makes sense why they were a matched pair. You put them together and you've got 29 dB, which is kind of standard for a lot of amplifiers that I've seen. So that's kind of just my take on how they actually are matched. So that's kind of my story on the Quad 405 clone board replacement and data, and I'm sure I'll get some comments from you folks out there. That would be nice. And if you like the video, always give it a thumbs up. If you have not subscribed, please do so. It helps the channel grow, of course, and I don't ask for anything else other than to subscribe if you like the content that I put out. So once again, I thank you for watching, and until next time, have a great day or night.